So we are here in a Python code that we have created for understanding of the overall how decision tree is working. You all know the import part, how a package is imported, and there is some column names present in the dataset, and these are the column names actually. So if I just try to run this code, and you see, if I try to print the data set, few lines of you know uh, examples in the data set, it's something like this, as you have seen. So these are some parameters on which we have to decide some outcome. Don't know exactly what this outcome signifies, but some outcome represented by binary classification 1 or 0. So what we have done here now, that we have decided these feature columns. These are our feature columns, and this will be the outcomes, and based on that we have just represented the x and y. Okay, so we have done this, and then why it is required, because we have to split the data set into two parts, that is x train, x test, and their corresponding y train and y test. And that is what we have done by train test split, and this is very known to you already. You have seen for last few days continuously this usage of this particular function. Fine. So we have created x train, x test, y train, y test. Now it's time for creating the decision tree, and it's again very easy. It's just you can create the, you can use this particular line, or you can call this function decision tree classifier, and not function, sorry, it's a class. So a CLF object will be created which will have a fit method, which basically tries to do this, finding this optimal split, what actually we have just discussed there in different way, where we have this x train and y train. Definitely these are the training data that we have, and as a result we have to find out what should be the predicted value from the test data set. And then what we can do, so let's do one thing. Let's just try to run this code, and we will run this, and it's done. Okay, now what we can do, we can check the accuracy of this. So if you just run this, you will see that accuracy is given 0.7099. So you can say its accuracy is almost near about 71%, which is not really very good, but just for understanding we can proceed further. So 71% cases are correctly classified, it means. Okay, now a very interesting visualization will come for you, that is what actually is created. So we can try to visualize the tree that has been made because of this decision tree algorithm. If you run this and if you see, you will see a lot of variables here, right? And where this Gini index value is present, and based on the number of sample and number of value, and now what is the class. So a lot of things are there, but as a result, this is, you can say, the decision tree that is created based on your data set you have trained. You can easily see it's very complex. The decision tree is very clumsy, so it's not possible to read each and every whatever present within this uh, particular tree. But one thing is that you can easily understand that how this, the decision tree that has been made here, right? So this is how a decision tree algorithm works. Now, definitely, this 71% accuracy is not good. We can make it better by, how we can do that? We can actually try to check how good the model is behaving by changing different parameters just we have discussed, like max depth, maximum features, number of features present in a particular decision node, or number of split, something like that. So this is how decision tree algorithm works. Now one thing what we can do, we can go further, we can move further to the next algorithm, which is random forest. So let's go back to the presentation again and let's move with the next algorithm.